Welcome to today's webinar, Accelerating Network Operations with Big Cloud Fabric's GUI, session number 3 on Fabric Visibility. My name is Angelique Medina. I'm the Senior Product Marketing Manager here at Big Switch, and I'll be your host for today's webinar. As we go through the presentation, please feel free to ask questions using the Q&A box on your webinar dashboard. If you're watching this video on demand and you have a question regarding today's topic, simply go to bigswitch.com/webinars and submit a question using the link provided. We also have some handouts for today's sessions, including product information on Big Cloud Fabric, plus information on Big Switch Labs. You can download those handouts on the right-hand corner of your dashboard. Joining me today is Cedric Hobbs, GUI Architect here at Big Switch Networks. And the agenda today is pretty straightforward. We're going to quickly recap the first 2 webinars in this series, provide a brief overview of Big Cloud Fabric, and then get right into the primary subject today, which is the Fabric Operations section of the Big Cloud Fabric GUI. So the webinar today is the 3rd session in a series focused exclusively on Big Cloud Fabric's graphical user interface. The intent of this series is to provide more in-depth information and exposure to the management interface through a series of guided walkthroughs of the different sections of the GUI. If this is the first of these sessions you're attending, I do encourage you to go back and revisit some of the earlier sessions, which you'll find archived on our website under resources. So the first webinar in the series introduced Big Cloud Fabric and provided an orientation to the GUI. And we'll also do a brief introduction to Big Cloud Fabric today as well. The second webinar in the series covered the concept of intent-based networking and demoed some related workflows. Today's webinar will focus on gaining greater visibility into the Big Cloud Fabric switching fabric through the Fabric Operations screens of the controller interface. But first, we're going to quickly review the Big Cloud Fabric solution and why there's a need for disruption in networking. So if we look at the data center today, we know that compute and storage have already undergone abstraction, and that's enabled much more efficient and, of course, flexible resource utilization, as well as the agility needed to support cloud-native applications. All of these changes in the data center have increased pressure on the physical network, which, despite innovations on the compute and storage side, hasn't really changed much in the last 20 years. And regardless of all the changes in the data center that have moved it towards more agile infrastructure, the agility of the data center ultimately depends on the physical routing and switching network. And unfortunately, traditional networking is still based on a box-by-box operational paradigm. Not only is this model inefficient, it's also fragile. So each switch within the network has to be consistently configured to prevent any one of them from creating routing errors. And provisioning the network for applications and other standard operations is quite time-consuming and complicated. And another disadvantage of legacy networks is that they rely on proprietary high-cost switches. So the traditional network simply doesn't support many of the demands on today's data centers. Today's data centers are experiencing higher volumes of east-west traffic and are also becoming increasingly software-defined. So basically, the traditional network has become a management bottleneck. So in looking at the networking paradigm emerging today, it's helpful to consider hyperscalers such as Google and Facebook, in that they recognized early on that the legacy approach to networking simply wasn't scalable. They needed to grow their network without incurring a proportional operational cost, so they created highly efficient networks that emphasized automation. And Big Switch Networks really internalized that philosophy, this philosophy of the hyperscalers, when it developed Big Cloud Fabric, which we refer to as the next generation switching architecture. By centralizing the control and management planes and abstracting discrete switches into a single logical switch operating as a fabric, the basic operations of the network get dramatically simplified, and automating data center specific workflows on top becomes much simpler. So rather than treat individual switches and routers as independent, autonomous devices, as we see on the left in a traditional network, here at Big Switch have basically, treat each of the individual switches as part of a single logical entity. And in order to consolidate the network into a single logical switch, we leverage SDN and a controller, and this provides the single point of management that we're going to focus on today. And once we have this single point of management, once we have this capability, it's fairly straightforward to integrate into a variety of systems like VMware and OpenStack and provide those systems network automation and analytics and intent-based interaction to various applications. So what we mean by intent-based is the ability to provide much higher level directives to the network fabric. So without specifying the details of execution, you can simply specify high level directives. So the intelligence of the controller managing the fabric is such that it's able to translate straightforward instructions representing user intent into specific network configurations. So Big Switch Networks effectively offers a new way to build and operate networks that improves availability and agility compared to traditional legacy approaches. So taking a closer look at Big Cloud Fabric, it's an SDN-based leaf-spine cloth fabric that provides layer 2 switching, layer 3 routing, and layer 4 through 7 service insertion and chaining. So this architecture, this fabric, provides physical networking that's simple to deploy and operate and enables faster rollout, faster scale out, and faster troubleshooting. And it also eliminates hardware vendor lock-in because BCF deploys on open networking hardware, hardware offered by vendors such as Dell EMC, HPE, or Acton. And we provide the network operating system to create and manage a highly resilient and scale out network fabric. So Big Cloud Fabric has a single interface with which to manage the entire switching fabric. And in addition to the graphical user interface that we're going to focus on today, there's also a CLI and a REST API. So that's also something to consider. But again, we're just going to focus on the GUI today. So the really kind of key thing about our GUI is that it's very visually and functionally rich. So it really wasn't developed as an afterthought. Our design philosophy is API first. And of course, we have a CLI, as previously mentioned, but unlike what you might see with other vendors, we don't really consider our GUI to be, sort of just a bolt-on. Many of our customers who've previously been, really hardcore CLI users have found that they prefer our GUI because, it provides a much simpler way to, to manage the network and to work through many workflows, and also offers some very useful visualization as well. So with that, I'm going to turn it over to Cedric, and he's going to introduce and walk us through the Fabric Operations section of the Big Cloud Fabric controller interface. So welcome, Cedric.
Thank you, Angelique. It's exciting to be here. Let's switch over here. So, as Angelique mentioned, in our first two sessions, in the first one we did an overview of the GUI. We looked at the dashboard, and we looked at some cool things like we talked about tables, which is, a big part of the GUI, and we looked at the cool 3D rendering of switches. And then in session 2, we drilled down a little bit deeper and showed how you can configure the topology, right? So you can drag switches to the leaf or spine buckets, and it's very simple to kind of configure roles for your switches. So in today's session, I wanted to drill down a little bit deeper even than that and focus on visibility. So we have this page called the Fabric Ops page, which is a more port-centric view. So it really still shows all your switches, but in a different, more of a heat map style, so we can see things like stats and features and things like that. So I'm just going to dive right in on one of our test beds. And I'm logging into the dashboard, and then I'm going to navigate to the Fabric Ops page. So just like on the Fabric page that I talked about last time, this page is divided into a sidebar on the left and a workspace on the right with a slider, so you can always optimize how much room you have. And really, you can already see that this is laid out by switch. I mean, it's grouped by switch, where the spine switches are at the top and the leaf switches are in the next row. Excuse me. And if there are any virtual switches, they're also shown in in the next section. So it is a little bit hierarchical, but rather than show a realistic view of the switches like we do on the Fabric page that I previewed last time, they're just boxes, right? Because we want to show really a heat map, right? I mean, this really kind of goes back to the one big switch, right? If you're looking at this, this is like one logical switch with a bunch of ports. And you already see some heat map features here. So I'm going to actually go through, we have 4 different map types, and by default, we're showing the we're mapping the port stats, right? So we can look at things like rates and counters and utilization on our ports. The next map type is features. So OpenFlow exposes all kinds of features about our ports. Is it copper or is it fiber? Is it 40 gig? Is it 10 gig, et cetera? And then we can also look at relationships between our ports and other things that are configured in the BCF. For example, I think I talked about in our first session how you can manage interface groups, which is really just a collection of ports, like port channels or lags, right? And so there's a way to see, which ports are members of the interface groups that you might configure, or which ports are included in a segment via its membership rules and things like that. So I'll demo that a little bit, and then I'll also show a cool demo of the links that you can show between these. And we did something similar on the Fabric page, but it was a little bit richer with some more options. So I'll start here with the stats, which is where it defaults to. And you can see on the top of the workspace, there's a gradient, right? So this is sort of your legend. So the very light pale blue is 0 bytes per second. And at the far right end is 6,200 bytes per second, and that's in a deeper blue. And so if you look at your workspace, you'll see that you basically have a heat map. You can see where all the hot spots are in terms of your rates, right? And so if I mouse over a port, I can see the tooltip. It'll show me the actual rate, 6 kilobits per second for this one in particular. So there's several places where the traffic is, close to the max or the max. And lots of the ports are pretty quiet. So this is just a good way to spot where most of the noise is on your network. So if I switch now to, instead of rates, if I want to look at counters, now I get another map, and you'll notice again at the top the legend has changed. And so now we're looking at the scale from 0 to the maximum counters in our system. So there's the max is 49 billion bytes. And I don't know if we'll be able to find that. But it's one of these darker blue ones. So you can see this one has this tells you more historically where is all the traffic sort of accumulated. And you'll notice with the rates and the counters, I have options. I can choose whether I want to map these rates and counters in bytes or packets. I can choose which direction traffic I'm interested in, or both, which is the default. And I can even segregate it by unicast, multicast, or broadcast traffic. So if we go to the third statistic type, utilization, we'll see the gradient has actually changed now. So this is a more normative sort of heat map, right? Because at certain values and above, there's some action might be required. So for example, if your utilization gets too high, you might want to do something to remedy the problem. So you see we have a really good heat map. Everything's green. That means our utilization isn't in any danger zone. But if there were any orange or red here, you would be able to identify where you might need to pay attention to your network. So the next map type is features. And the first thing by default is copper, but you'll see that there's a list of different features I can map. So instead of showing a gradient, this is just really more of a kind of an on-off, right? Does the port match this feature? If so, it'll show up in blue. If not, it'll just sort of not be lit up. So you can see here all these blue ones are the ports that are copper in our system. And if I scroll through this list, I can also see a list show a map of all the ports that are fiber. And I can kind of go through full duplex, half duplex, all these kind of interesting features that are provided by the OpenFlow spec. I can see where my 1 gig ports are. There's none in this system. Now I can see where my 10 gig ports are. And if I click again, I can see my 40 gig ports. So hopefully you get the idea. And this second drop down is sort of a typology also exposed by OpenFlow. So you're usually only going to be interested in the current features, but there's also supported features, advertised features, and peer features that you can map. Another option here is the combination. So if I choose combination from this first drop-down, I can sort of construct a more kind of complex mapping. So for example, if I want to see all my copper ports that are 10 gig, I would sort of uncheck all the other ones. And since I want to match both of them, I want to match all, not any. And so voila, at the end I see there's a bunch of ports lit up that are both 10 gig and copper. So you can build more complex map types just by using this combination. Now, sometimes that won't make sense if you do, 10 gig and 40 gig, right? That's not going to match anything probably. Or copper and fiber, that's not going to match. But you have all the power you need to kind of construct whatever kind of maps you want to see here. So that's a really powerful tool. So the third map type is really relationships between ports. So as I mentioned, you can configure an interface group, which is really a collection of ports. And you can already see from the first interface group it's showing, which is this overcloud-compute-0. This is the first one that's in the list, so it's already automatically selected. And you can see in our workspace that there are 2 ports that are showing up in blue. So these are 2 member interfaces of the interface group. And if you look at the top, there's another legend where not only can we show membership, but we can show types of membership. So an interface group can have primary member interfaces and backup member interfaces. So if any of these ports were actually backup member interfaces, they would show up in orange. So right now there's just 2 blue ones, so they're both primary member interfaces. And if I mouse over, I can see more details. And so I can sort of cycle through the different interface groups by clicking these little arrows to click through the list and see how the map type changes. I think there's probably one on this system with some backup. See if I can find it. Probably not. Anyway, I think you get the point. Most of these just have a pair of ports in the interface group. So one thing that's kind of neat about this particular map type where we're looking at relationships is that we can actually manage those relationships from here. Now, to manage an interface group, you have to give it a name, and you can specify some options. But in terms of just specifying members, you can do that from here. So for example, if I wanted to create a new interface group, I could actually start that workflow from here by clicking the Create button. And when I do that, you'll see that I'm in configuration mode, and it's blinking because it wants to make sure that you know that that's not a permanent state. You need to kind of do your configuration and then get out of it. But you'll notice that a subset of the ports are actually sort of highlighted in a lighter gray, and these are all the ports that are actually available to be used in an interface group. The ones that are not highlighted are the ones that are either already used in an interface group, which means they can't be reused, or the spine or virtual switch ports. They're not eligible for interface group membership. So an interface group has to be defined on a leaf switch, actually on a pair of leaf switches, 2 leaf switches that are in the same leaf group, which would sort of be the same rack. So all these ports are available because I have nothing selected, but you'll notice that as soon as I select one, my available choices are now winnowed to the leaf group on which that first port belongs. So that's constantly updating what you're allowed to click, right? So I could click a port. If I click again, it'll cycle through the types. I talked about the primary and backup up here. So if I click the same port a second time, it'll turn orange to indicate this is the backup member interface. Or if I click again, it'll turn it off. So I can build an interface group this way, and if I'm finished selecting my ports, I can click Continue, and it'll launch the dialog for finishing the interface group. And this is required because, again, you have to give it a name, and you might want some other options selected here. But you'll see that the graphical display on this dialog is already filled in with the selections I made on the Fabric Ops page. I'm just going to cancel this because I don't want to mess with this setup. And similarly, I can do modify, and the 2 members that are already selected will already be selected, and I can continue to add or remove ports from this group. So this is actually a pretty powerful tool. And right now, we've also got map types for tenants and segments. We haven't talked about that too much, but a segment can have membership rules for ports, and it can either do that directly by including specific ports, or it can include ports through interface groups. And so here's another map type that we can see, and there's a legend at the top that shows how the membership rule is including the port, whether it's direct or through an interface group. And then we can do the same thing for tenants, so basically looking at all the segments in that tenant and sort of get a rolled up view of the ports that are included in that tenant by membership rule. So here we haven't exposed the configuration workflow, but the idea of this area, this mapping type being about relationships, the idea, of course, is for this to grow and expand over time as we add more features and relationships. So the last thing I wanted to show is the links, and we showed a little bit of a preview of this on the Fabric page in the last session, and you'll see a sort of similar style. And right now I'm looking at the links, all the links between the ports on my physical switches. So let's talk about this a little bit, because right now it looks like spaghetti and it's a little hard to discern. So by default, they're all drawn in a straight line. But the problem with straight lines is that they can overlap. For example, these two links, there's two links here that I'm looking at that are actually overlapping. So it's hard to tell that there's two links here. So the first thing I might want to do is add some cable sag to help differentiate those links. And what we do when we change the cable sag is, I don't want to get too technical, but what we do is define a range, and then how much sag in the cable is actually randomized. So it helps us make sure that we don't get overlapping links. And then I can mouse over the different links and see which ports they're connected to. You'll also notice the endpoints of each link have green boxes around them, so that corresponds to the utilization map that we saw in the first map type. So if I'm looking at links, I probably also want to see what the utilization looks like on either end of the link. So again, I can adjust how much sag I want to use. I can adjust the thickness of the cable. Some people like to see it real thin, and some people like it. It's like the difference between, I guess, angel hair pasta and fettuccine, right? Or so we can. The default is normal, where it's just a couple pixels wide. And you'll also notice that you can change the cable colors. And in fact, you can select a set of colors. So I like orange and purple because they're not very normative colors. And I'll turn off the blue. So now I've picked two colors, which means the links are basically randomly selecting between the two colors in my pool. And you'll also notice that there's a little bit of shading, and we add a little bit of white or black to the color. And that actually adds some depth. If these were all sort of a monotonous color, it wouldn't look very 3D, and it would be harder to differentiate the links. Another feature we can do here, which may not show up too well, is if we want to sort of limit the links that we're seeing by the utilization range. So if maybe I only wanted to see all the links where my utilization was 50% or higher, I could change this slider to define what range of links I want to look at. And in this case, it's going to dim all the links because none of them are really highly utilized. Might have to go way down to 0. That doesn't really, yeah, there's not much traffic on this, so that's not going to show up as well. But the idea is that you can limit which links are showing up based on the utilization, so you can really zero in. Another way to sort of make this a little bit more digestible is to, I mean, by default we're showing all the links, but if I wanted to show the links just for a particular switch, I could use this single switch dropdown. And when I select a single switch, it just shows the links to and from that one switch. So right now we're seeing all the links to and from leaf 0A-Z9100, and this is actually useful. So A, it makes it a little bit clearer, and also it's a good way to visually identify some requirements we have in the leaf spine topology, right? Which is that every leaf has to be connected to every spine, and every spine has to be connected to every leaf. So, you know, one thing I like to do is just sort of scroll through the drop-down list with these up and down arrows, and just visually start identifying, is this leaf switch connected to every spine switch? It's very easy to see these 3 linkages up here. Yes. So I can sort of kind of scroll through and visually identify, visually sort of confirm that my configuration is correct. So that's kind of a cool thing to do. And similarly, once I get to the spine switches, I can start scrolling through and just visually inspect, make sure that they're all, each spine switch is connected to every leaf switch as I scroll through here. So that's a very cool feature. And that is the Fabric Ops page. Hopefully, you know, it's a great tool for folks to get visibility into their network at a port level.
We actually have a question. So there's a question on how do I see what the speed is of the interface group?
The speed of the interface group? Well, that would depend on the member interface, the members, right? So there isn't a speed for an interface group, I don't think. But you know, you could actually go to, let's see, if I wanted to see the interface group, where are we? Oops. we have an interface group there, right? So we're not showing the speeds there, but it'd probably be probably easy to add the speed to the tooltip if you wanted to see the individual member speeds. So we only show that when we're mapping the speeds, but we could probably add that if people found it useful.
Okay, and then we also have a question, is there a way for me to see which ports have a specific MAC address or IP address?
Oh, that's a good question. I sort of skipped a feature here, which is this search box. This is actually a pretty powerful tool because, it actually auto-completes, and gets keywords from every switch and every port, including the interface name, speeds, MAC address, IP address. So let's actually demo that. In fact, I showed a map type where we could sort of use the port features map type to look for all the 40 gig ports, but I could actually just enter 40 in my text box, in my search box, and it'll already start highlighting the 40 gig ports. And this is actually going to be the same set of ports that I saw when I looked at the port features, when I manually clicked the 40 gig. So in fact, I can do a search on IP addresses. In this case, subnets are actually kind of already auto-completed. So this particular switch you can see is all on this subnet 10.9.16.100/23. And as I scroll through all my auto-completed, I can see where all my different switches are, which subnets they are. So I can look up specific MAC addresses or IP addresses here. I can look up a MAC address. Let's see. I think these start with 5C. All right, so 5A, 5C. So it's auto-completing a lot of MAC addresses. But if I know exactly which MAC address I want, I can start entering it here, and I'll see it mapped here, highlighted in the workspace. I think there's also MAC addresses for the switches, right? So those start to get highlighted too as we scroll through. Good question.
So we have another question. So can we map a color of a link to a specific physical interface?
No, right now that's just you're just selecting a pool of colors, and it's hashed and randomly selected. Yeah.
And then, so there was a question from someone who attended the last webinar, and they're asking if you can talk more about the logical topology that was mentioned.
Sure. So I'm going to demo this on a different setup, which is just sort of my development little sandbox. I think last time for about 30 seconds I talked a little bit about this, and I didn't get the view to look like this. But tenants are really all pretty uniform. There isn't as deep a topology. I mean, all tenants are the same with a couple of exceptions, right? So there's a system tenant, and that's identified by naming it system, which is pretty straightforward. And then we have a concept of an external tenant, and this is identified by looking for a default route from the system tenant with a next hop to another tenant. So that other tenant becomes the external tenant, and this is how traffic is sort of routed to the outside world. And so in this topology, we actually show the system tenant sort of at the heart, and then every other tenant sort of feeding into that system tenant. And then we sort of show an external tenant at the top with any segments belonging to that external tenant off to the side. You'll see some links here. So for a tenant to be able to communicate with a system tenant, it needs to have sort of bidirectional tenant interfaces configured. So you'll see in this case there's a green link because both of those are configured. In this case there's a dotted orange link because only one of them is configured, and then this dotted black link means there's no tenant interfaces configured. So if I start with this middle one, which is sort of halfway done, I can see that the connection to the system tenant from the remote tenant is already done, but I need to configure the other direction. And so once I do that and submit, you'll see that the link turns green, and that means the tenant is connected to the system tenant. And I can do the same thing for the connection between the system and the external tenant. So that's sort of a limited topology view we have of the tenants in the logical space.
Very good. Okay, so there's a question on, this might be somewhat outside the scope of just a GUI walkthrough, but I thought I saw leaf-to-leaf connections. Why would that be?
Oh, so that would be for your leaf groups, right? So if you pair two 2 leaf switches and a leaf group that corresponds to your sort of dual top-of-rack switches. They are going to have some leaf-to-leaf links.
So again, just for our audience, if you have any questions, feel free to enter them into the Q&A box on the right-hand side. So we'll leave that open for just a second. And what I would just mention while we're waiting to see if there are any other questions is that we have a very well-developed lab that is free to sign up for, and it basically enables you to have a sandbox where you can, you can basically dive into the details and play with either product. So today we're just covering the interface for Big Cloud Fabric, which is our switching fabric, but we also have a monitoring fabric that supports delivery of traffic to both out-of-band as well as in-band monitoring and security tools. So you can, for any of those 3 products, you can go to our website and you can sign up for free access. And so it's a really great way to kind of get that hands-on work into the product.
Can I just add real quick that Fabric Ops page is actually, there's a version of that on the big monitoring Fabric GUI too. So if folks like that, they'll like it on both products.
Great. And also, I would also add in the labs that we also have specific modules that cover our integration with OpenStack, as well as VMware vCenter, and also coming very soon, we're going to have a container Kubernetes module that you can, again, you can create your own sandbox and you can actually play with it. So very cool stuff. And so we have a question regarding the logical topology that you showed, and that is for tenant-to-tenant communication, is that all done through the system tenant?
I'm probably not the person to answer all of that, but I believe so. I mean, if you want 2 tenants to communicate with each other, they've got to be able to sort of link up through the system tenant. So I believe that's the case, yes.
We have another question. If there's any question, because again, this is more about the walking through the kind of the design and the options available for the graphical user interface. So if there's any sort of network-related or networking-related questions that we won't get to here, we'll follow up and we'll have one of our SEs handle that. So coming up for our next webinar, we're going to be hosting a webinar through XDX Central as part of their security report that's coming out in a few weeks. So the theme of the webinar is leveraging SDN for dynamic scale-out network defense and security monitoring. So again, that will be hosted by XDX Central. We'll be sending out additional information about that this week and in the coming weeks. So we encourage you to go to either our website or xdxcentral.com, and you can sign up to get additional information about not only the webinar, but also the security report that's coming out. And with that, we will go ahead and close out the webinar today. We really appreciate you joining us. And if you would like to see not only an archived version of this webinar, but all of our previous webinars, you can go ahead and go to our website. It's bigswitch.com/webinars. And again, we highly encourage you to check out our free labs. So with that, have a great day.